Hi, welcome back to Drafting 110, print reading for welders. My name is Anne-Marie Harden, and I will be your guide through this course. We're going to start by talking about weld prints in general, as well as a little bit about how weld prints have been generated in the past and how they are generated most of the time now. So we'll define prints, we'll define working drawings and specifications. Those are all types of drawings. We're going to talk about the processes that have been used to produce prints from drawings. And we'll talk about the difference between prints and drawings. And we will talk about conventional drafting methods as well as a little bit about computer-aided drafting methods. We're also going to talk a little bit about the pieces of the computer system. We kind of take a lot of this for granted now, but it's a good idea to remember what we mean by input device and output device. Like many things in engineering and industry, the paper sizes that we print on are standardized, as are lettering and zoning, and so we will talk through that a little bit as well. So a print is what most of us see when we get a drawing. A print is a reproduction of a working drawing. And a working drawing can be more than one document. It's a set of plans that contains information necessary to complete a job. It can be multiple sheets, it can be multiple prints or multiple, like I said, what we think of as drawings, but they're actually prints. And a specification is a document that supplements the working drawings with written instructions, gives information beyond what's just included in the drawing. So let's talk about how prints were originally made. Blueprints were the original prints, and they actually began to be used in 1840. This is an example of a blueprint. This is an example of a blueprint. They were actually blue pages with white lines. That was the original drawing. And this, like I said, they began to be used in 1840 when a method was discovered that would produce paper sensitized with iron salts that would undergo a chemical change when exposed to light. And so you would get prints that had white lines on blue backgrounds. Today, our prints look more like this digital image. They are white backgrounds with black lines. They're produced much the same way that we print paper letters on a laser printer. If it's a manual scan drawing or a manual drawing, a hard copy, we can scan it in and then print a photocopy, essentially. If it's a digital file, we'll print it to a big format laser printer. So originally, starting in 1840, prints were blueprints. That's why you sometimes still hear the term blueprint. Now that we're in the digital age, we tend to have more what we think of as conventional prints with black lines on white backgrounds. Working drawings can be made either by hand, like this person is doing, with conventional tools that are T-squares, triangles, manual scales, compass, and a pencil. That's a very tedious, time-consuming process that requires great attention to detail and a fair bit of manual artistic talent. More often today, prints are created using computers, computer-aided design software. AutoCAD by Autodesk is one of the most frequently found. SolidWorks is coming into its own, is becoming more popular, although SolidWorks is mostly thought of as a three-dimensional program. It can do two-dimensional work as well. AutoCAD can also do both two-dimensional and three-dimensional, but AutoCAD started as two-dimensional, moved into three-dimensional. So they both have their strengths. But whenever you see CAD, what you should think is computer-aided design. Now, computer-aided design benefits engineers and designers creating the drawings because it's quicker and the prints are more consistent, and you can make more drawings in a day. You can be more productive. You can also apply company-wide standards more easily to things like title blocks, and make sure your symbols are the same every time. For example, this could be the symbol for this particular assembly every time it shows up. Even with the best of manual drafters, there's a little bit of personal variation. Trades workers, welders in this case, who are reading CAD-generated plans benefit because of quality and consistency of the line work, symbol representation, and the lettering. Now, CAD systems use hardware, and hardware is the computer itself, the box with the motherboard and the memory in it. That's the hardware. The drive is a piece of hardware. Running on that hardware is software. So things like your Windows operating system is software. Your AutoCAD program is software. Word processing programs are software. Software is what actually creates the drawings. People interact with the hardware and the software via input devices. A common input device is your mouse. This guy. Or your keyboard. That's how we input print. Many designers use a graphics tablet, and I happen to be using a little one like this. It's just a little tablet with a little pen. That's how I move my mouse around. Varieties of other input devices, joysticks, thumb wheels, trackballs, touchscreen monitors. The touchscreen on your phone or tablet is an input device. We put information into computers with input devices. We get information out from computers with output devices, and examples of output devices are monitors, printers, speakers. Those are examples of output devices. You have to have all those components in order to make a computer system work. You have to have the hardware to run the mechanics. You have to have the software to run programming, the input devices to get information in, and the output devices to get information out. Without any one of those components, the computer system is not useful. Like many things in industry, paper sizes are standardized. We talk about paper sizes in the US as A, B, C, D, E, and F, G, H, J, and K. If somebody says, I want D-size prints, they want 22-inch by 34-inch prints. If they want B-size, they want 11 by 17. It's very common in industry to talk about B-size, C-size, D-size, as opposed to inch size. Just like when we're working in an office, we talk about letter paper and legal paper. A through F generally are flat sheets that you feed into your printer. G, H, J, and K generally are rolls. Actually, often we'll print everything from D up off of a roll stock. The thing with sizes G, H, and K, only their widths are specified, and you can have a length up to 90 inches for a G size and up to 143 inches for a K size. Whereas if you're printing, say, a B size, you're printing 11 inches by 17. If you need a print that is 11 inches wide by some unknown length, you'll want to print a G size. So you'll print 11 by however long you need up to 90 inches. Europeans' paper sizes are also standardized, but they're slightly different. They are standardized by a letter and a number, A4, A3, A2, A1, and A0. And in this table, which is also found in your textbook, you've got the nearest USA sizes. So, and also notice the width and the length are in millimeters because it's European. The interesting thing about European sizes, there is actually a relationship between the length and the width. If you know the width, you can always find the length by multiplying by the square root of 2. All drawings have a few things, all drawing sheets have a few things in common. The round corners are optional, and truth be told, I don't see those very often anymore. I mostly see square corners on all 4 sides. However, you will always have a horizontal top margin of 3/4 of an inch, a vertical margin on both sides of 1/2 inch, and there's also, notice, a bottom margin of also 3/4 of an inch. So top and bottom margins, 3/4 of an inch on an A size, and 1/2 inch, or on C size, and left and right margins of 1/2 inch. On a D size, things are a little different. You've got top and bottom margins of 1/2 inch. And on an E size, you've got top and bottom margins of 1 inch. So your page setup varies by your print size. But they will all have margins, and in these margins, there will be letters and numbers. Numbers going across the bottom, letters going up the sides, and that's to aid in finding things on prints. And some of these prints can get quite busy and quite cluttered. Lots of information crammed into a tiny little bit of space. So it can be helpful to refer to a zone, and the zone is referred to by a letter and a number. So for example, if this is number 7 and letter B, so the rectangle that is defined by 7B is this rectangle where those zones intersect. All drawings will also have a title block, and there's a lot of information included in this title block, and we will talk about that, but it's important to understand how to read a title block. And most drawings will also have a revision block. Now the revision block can be in different places. This one happens to be in the upper right. I've also seen revision blocks just located down here at the bottom to the right of the title block. The title block is almost always in the lower right-hand corner of the drawing. And the zones are standardized, again, by drawing size. So on a C-size drawing, you're only going to have 4 zones of 5.5 inches. On a D-size drawing, you're going to have more zones of 4.25 inches. On an E-size drawing, you will have multiple zones of 5.5 inches. The vertical zones will be 4.25 inches. The title block, as I mentioned, has got a lot of important information. It is always located in the lower right-hand side of the drawing. I've never seen one in industry located anywhere else. That has to do with how we fold these prints and how we file them. Important information in the title block. There will be a company name and usually address. There will be some information about who prepared the drawing. There will be a drawing title and number. The drawing number is an important way to refer to the drawings, and it's actually far more common to refer to drawings by their numbers than by their titles when you're working in industry. There will be a drawing size. Now this is really important to understand the original size of the drawing, particularly if the drawing was drawn to scale. And so say you have a C-size drawing that somebody has reduced to a B-size sheet. That happens. It's acceptable, but it means your scale is going to be off because you have reduced the drawing. So you need to be aware of the relationship between these two. The FSCM number is a standardized number that is sometimes required for some items. We'll talk about that later. A sheet number. I mentioned earlier that that working drawings can be multiple sheets. You will find the sheet number as well as the total number of sheets in the title block. Drawings are almost always reviewed and approved by somebody other than the person that draws them, and this is where the approval information will be found. And your subcontractor, your contractor can approve them. So, for example, if you're working on a project for a customer, this will be where the customer signs that they have approved the drawing. It's part of your protection that the work you're doing is what they expect you to be doing. Specific sizes of title blocks vary both by sheet size and by company. Not so much by drafter anymore, because the drafter is generally going to conform to a company standard, unless you are running your own company, and then you can create your title block however you would like it. But these are some fairly representative title blocks for common drawing sizes. A lot of times you'll also see a parts list or a bill of materials, and it will appear usually above the title block, and it can be on either the left-hand or right-hand side of the drawing. And that's an indication of what's needed to build the part you're building. Okay, so quick review. By the end of this chapter, you should know what is the difference between a print and a specification. You should be able to talk about the basic tools used to produce working drawings by the conventional method. And be able to talk about what's an input device, an output device, what's the difference between hardware and software, and a list of the letters designated for use of flat sheets and rolls, and be able to locate the title blocks and zones. So for this chapter, read the chapter and review those review questions at the end of the chapters, and then take the chapter quiz. And I'll talk to you again soon.